Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 47, Supply Chain Security. Alice, this is a topic that's been in the news a lot. SolarWinds, Log4Shell, XZUVels. But before we get to those, let's set the stage. What does supply chain mean in a software context?
Think about your legal SaaS platform. A contract review tool, a case management system, whatever you're building. You wrote the business logic, but you didn't write the web framework. You didn't write the PDF parser. You didn't write the encryption library or the database driver. A typical application has hundreds, sometimes over 1,000 third-party packages that it depends on. And each of those packages depends on other packages. Those are your supply chain. You didn't write 95% of the code in your application, but it all runs with the same privileges, accessing the same client data.
That's a lot of code you're trusting without having read it.
Exactly. And 3 major incidents in the last few years showed what happens when that trust is misplaced. SolarWinds in 2020, attackers compromised the build system for a network monitoring tool. They injected a backdoor into the legitimate software update. Over 18,000 organizations installed it, including US government agencies. The backdoor wasn't in the source code. It was injected during the build process, so code review wouldn't have caught it.
Right, and Log4Shell.
December 2021. A critical vulnerability in Log4j, a Java logging library. The scary part wasn't just the vulnerability itself. It was that thousands of organizations couldn't even figure out if they were affected, because Log4j was buried deep in their dependency trees. It wasn't a library they'd imported directly. It was a dependency of a dependency of a dependency. They didn't know what was there.
And XEUMIL was different again, right?
That one is the most unsettling. A threat actor, going by Tan, spent years building trust as a contributor to XEUMIL, a compression library used in virtually every Linux distribution. After gaining maintainer access through sustained social engineering, they injected a sophisticated backdoor targeting SSH authentication. It was discovered by accident when a developer noticed strange performance behavior. The code had already been included in several Linux distribution pre-release builds. Years of patience for a single supply chain attack.
3 different attack vectors. So how do you defend against this?
Step 1. Know what you have. That's where an SBOM comes in. SBOM, Software Bill of Materials. It's a comprehensive inventory of every component in your application. Every direct dependency, every transitive dependency, that's the dependencies of your dependencies. Their versions, their licenses, their origins. Think of it as a list of ingredients on a food label. You can't manage what you can't see.
Right, and this is now a requirement for government software, isn't it?
Yes. U.S. Executive Order 1428 requires SBOMs for federal software procurement. CSAT published minimum elements in 2025. Component name, version, supplier, dependencies, unique identifier, and timestamp. Generating one is a single command in most ecosystems. For a Node.js project, you run a Cyclone DX tool and get a JSON file listing every package. For legal SaaS, BSBOM serves security teams tracking vulnerabilities, legal teams checking license compliance. You don't want an AGPL licensed library in your proprietary product, and incident responders who need to answer, are we affected, when the next Log4Shell drops.
So the SBOM tells you what you have. What tells you what's wrong with it?
Dependency scanning tools. Dependabot, Snike, OSV, they continuously monitor your dependencies against vulnerability databases. When a new vulnerability is disclosed that affects one of your packages, they alert you or automatically create a pull request with the fix. The keyword is continuously. An SBOM generated at build time is a snapshot. Continuous scanning catches vulnerabilities discovered after you've already deployed.
Yeah, and I imagine you also need to make sure you're deploying exactly what you tested. not a different version that got updated between test and deploy.
That's lock files. When you run your package manager, a lock file records the exact version of every dependency installed. Not a range, the exact version. You commit that lock file to your code repository. Then, in your CI/CD pipeline, you use a deterministic install command that reads from the lock file and installs exactly those versions. If an attacker publishes a malicious version of a package that falls within your version range and you don't have a lock file, your build process could silently pull in the malicious version.
That's a simple thing that prevents a serious attack. What about the build process itself? SolarWinds showed that even if the source code is clean, the build can be compromised.
That's where SLSA comes in. SLSA, Supply Chain Levels for Software Artifacts. It's a framework that defines levels of build integrity. The SBOM tells you what's in the software. SLSA tells you how it was built and whether you can trust the build process. At level 2, your build system generates a signed provenance attestation, a cryptographic document proving what source code was built by which build system producing which artifact. It's like a notarized affidavit for your build process.
Right, and if someone tampers with the build, like the SolarWinds attackers did, that provenance wouldn't match.
Exactly. The signing uses SigStore, the same keyless signing we mentioned in episode 46 for container images. The build system authenticates with its identity, gets a short-lived certificate, signs the provenance, and records the signature in a transparency log. No long-lived keys to steal. And level 2 is achievable for most teams in 2 to 4 weeks using GitHub Actions or Google Cloud Build.
Let me ask the legal angle. If you know a dependency has a vulnerability and you ship it anyway, what's the exposure?
Real. Awareness of a vulnerability plus failure to remediate creates a duty of care issue. If a breach exploits a CVE that was publicly disclosed months before you patched, your answer to "why wasn't this fixed" needs to be better than "we didn't know." A BA Model Rule 1.6c requires reasonable efforts to prevent unauthorized access to client information. Running a legal SaaS platform with known unpatched vulnerabilities in your dependency tree is hard to characterize as reasonable. The SBOM and continuous scanning are your evidence that you took it seriously.
Yeah, that's compelling. So to summarize, SBOMs for visibility, dependency scanning for alerts, lock files for reproducibility, SLSA and SigStore for build provenance.
4 layers that transform your supply chain from a blind spot into a managed risk. Without them, you're shipping software you cannot fully describe, built from components you cannot fully verify. With them, you can answer, to regulators, to clients, to a court, exactly what's in your software and how it was built.
Next episode, environment configuration and secure defaults. How to make sure your staging and production environments have the same security controls, not just the same features.
Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.